everybody, this is Terry Rysat at Foundry, and we're going to look at Gaussian Splats. So let's get started. A couple of ways that we can bring in these splats. We can use a geo import and point at a .splat or a .ply file. Or we could use a geo reference node, do the same. But what we're going to do in this case is I'm just going to drag and drop from my file browser the file directly into the node graph. So when we go ahead and look into the 3D viewer, we can see we have our splat. It's looking pretty good, but the orientation is off. And that's pretty common when you're building your splats. You're using an external program and then bring them into Nuke. We have to correct the orientation. So we can do that with a geo transform. In this case, I know I need to rotate it 180 degrees in the Z. And it's a good idea. We could be saving a preset for this rotation for the splat. Okay, so looks very good. And what we're going to do is the task we'll do is duplicate this picnic table. We're going to move it elsewhere, and then we will help better integrate it. And this will be a good way to show some additional nodes and workflows here. So the first thing we're going to do is look at a new node, and that is a part of a new system called the Fields system. This is new inside of Nuke, and you can see we have a set of nodes here, and we'll talk about additional field nodes that are hidden. Now, these are quite interesting because the nodes provide the ability to non-destructively mask 3D data, including Gaussian splats. Now, this is introduced as a part of the splats workflow, but the possibilities here go far beyond that, and we'll experiment with that a little later on. So I'm first going to make a field shape node. Now, I don't want to plug it in to the node graph just yet. I want to get it into position. I don't want any overhead of calculation, so I'll just put it right around here, and then we can change the shape of it. Currently it is a sphere, but what I'm going to do is change it to a box, and then I will begin to manipulate the handles here like this. Now we're going to break this off into two parts. I'm going to do the lower picnic table and then the upper picnic table. We could probably encompass it all in one, but I think we'll be able to see some other interesting workflows this way. Okay, another nice thing that we can do with the field nodes is we can visualize them because it can get tricky. We have a lot of visual information going on here, and I want to be able to see what's being encompassed within this box. And so if we switch over to the display tab, we can draw a preview. And what that does is it fills in our box with a volume, and we can adjust the opacity on that. So this way we can see how much of the object we are covering. And this is looking pretty good. All right, so now that we have this initial shape, what I'll do is I'm going to just copy it and paste it. And I'm going to move it a little bit higher this time here. And I don't want to grab anything extra, so I'll just make an adjustment here. All right, so now what we'll do is we're going to delete some splats. So we will create a geo delete points. So with the geo delete points, we plug it in our chain, and for the mask input, we'll plug in field shape 1. So when we do that and have a look through the points node, we'll see that, well, there we go. We have removed the bottom of the table. We could probably tweak the field shape a bit further, or try and squeeze a little bit more out of those table legs, but it's looking pretty good, and our floor looks to be still intact, which is what we want because we only want the picnic table. Okay, now we have our second field shape. So what we want to do now is get another new node, which is the field merge node. And from here, we'll plug in our two field shape nodes. And then in this case, this will now be our mask. All right, so this is not the result that we're looking for, and that's because the operation is not correct, right? So we have it set to add, and what we want to do is actually have a shape union. So if you think about this like a Boolean, we're going to be combining these two shapes. There we go. So now we have essentially removed the picnic table. Now, this is not our task. We don't want to remove the picnic table. We actually want to duplicate it. So let's look at how we can get the inverse of this. If we select the geo delete points, we can invert the point mask, and that will give us the picnic table. But another way we're going to do this is we're going to use a field invert node. And that means when we plug it in, everything behind this node will be inverted. And this is more along the lines of what we need. Now, I'm going to do one more thing is I'm going to copy that initial shape and I'm going to clean up a bit more. So what we'll do is bring it below the picnic table and get all that stuff on the inside. And then we can also merge this back in. What we'll do is create another field merge. And for this one is field shape 3. And in this case, we want to do a difference. So we'll do a shape difference, which we'll subtract away. And then now we have our picnic table. So we could go in and further maybe tweak a bit more, but it's actually looking pretty good. I think this will hold up quite well. So let's leave this as is. All right, so at this point, we now have the picnic table isolated. I'm going to move these nodes over. And we want to begin to merge this. So what we'll do is create a geotransform. And for this geotransform, I want to adjust the pivot. Right now it's at 0, 0, 0. So I will hit Control or Command on Mac and then just move that pivot into somewhere more logical so I can control the table a bit better. So that looks pretty good here. All right. Now I'll plug my geo points into this, and now we have our picnic table ready. So we want to merge our initial splats with the isolated picnic table. So what we'll do is we will create a geo merge, and we will plug our splats into B, and then our picnic table into A. And let's have a look through the geo merge. Now, once we do that, we can see we are only seeing our isolated picnic table. We're not seeing our initial splat. And that is because if we look at our scene graph, we have georeference 1, which is our node that brought in the splat, and this is the name of the splat file. And then from there, we branched off. So this is where it lives in our hierarchy. We're branching it off and merging back on. So the thing is, we're actually merging it back on top of itself in the exact same path in the scene graph. So what we need is a unique location for this branch. And that's okay because that's what the geo merge has the merge modes for. So we can just switch it to duplicate prims. And once we do that, we can see that we have everything directly in our viewport. So if we look at our scene graph again, we'll see now that we have two entries here. We have our original and then the copy where we merged. Now we can also change some things here. We can change the name. I'll just change this to table. And we'll leave the index the same. So now when we look at the scene graph, we have georeference 1, table 1. All right, looks good. So now we are ready to move the table. Let's go ahead and do that. And that looks pretty good. We're almost on the street, but that should be okay. And maybe I'll just put it down a bit. And that's pretty good. So now we want to better integrate this. If we look at the other tables, there is a shadow underneath them. So for this, I'm going to create another field shape. And again, let's rough out the position of where we want it to be. So like this and right about here. And we're going to switch this again to a box. So I will put this into position, just sort of get an area here. Okay, looks pretty good. Now we're going to create another new node, and that is a geograde node. And this grade node works in the 3D pipe here. So I'm going to plug it in. We're going to plug it in to directly where our main splats are coming down, our background. We don't want to color grade the isolated picnic table. And then I will plug the field shape that we just made into it. And then let's go ahead and we're going to gain down on this, something like 0.6. And then now we are beginning to create the shadow. Now let's take a look at this a bit further. If we isolate this area here, we can see that we have our box and it is very harsh. And that is because, you know, our field shape, it's encompassing the volume inside of here. And this is where the geograde is being affected. Now we can correct this. We can create a field shape to density node. And when we create the field shape to density node, we have the option to feather. So I'm just going to go ahead and crank this up. And once we do that, you can see we have a nice fall off. It's feathering the shape for us. All right, so now we merge back on top and have a look, and that's looking pretty good. Maybe just 0.55. There we go. All right, so I think we are ready. We did our task. We were able to isolate the picnic table. We are having it better integrated in by color correcting the splats. So what we'll do next is actually quickly set up a camera in position before we render. So I'm going to create a camera and just get it into an area. Now, when we do this, like to make a new comp viewer, I'll just split it off to the side. And then inside of here, we'll look through camera 1, and then we can make our adjustments. So let's change that focal length to something like 35 or 22. And maybe we want to just pull back a bit more. Something like this is pretty good. All right. Now, before we render, we can do another thing here. We've done modifications to this, and what we can actually do is write these changes out to disk. If you think of it a bit like in the 2D world, we're going to pre-comp something. Well, we're going to write this out into a file so that we don't have to process these nodes anymore. So for this, I'm going to create a geo export. And for the geo export, you'll see that the default is set to Alembic, but we can also change it to something else. There's the ability to write to a PLY file, and we can actually change the level of the spherical harmonics. But in this case, I'm actually going to write it out to a USD file, as might be useful in other areas. So I'm going ahead and place a path, and then we'll get it going. Okay, so now that we have my path, I'm going to execute this. Only need one frame of this, so I'll hit OK, and then it will begin to render it out to disk. So this process, the length of this process may depend on how complicated our splat scene is, how many millions of splats are inside of here, how many millions of points are inside of here, but I don't think it's going to be too long for this particular one. Okay, it's done. That took about 45 seconds, so we're ready to bring the written out splats back in. This time it's a USD file. So let's go ahead and I'll drag and drop it in. And since this is a USD file, I'll be presented with the import scene graph dialog. I can see that we have our table as well as our initial splat. So I will say OK, and let's have a look at it. So looks good. There's all of our changes. We have the picnic table. We have the color grade that was applied to it. So now we will continue to do some additional compositing. So now we want to render our splat. So we have a splat render node. It's a dedicated node that we can be rendering splats with. Similar to the scan line where you can see we have a camera input, a background input, and a scene input. So I will plug the geo import into the splats and then into the splat render, and then the camera into the output. So let's go ahead and look at the render. All right, so we rendered, and one thing we notice here is that the color appears to be off. The color space is incorrect. If we look at the splat render, you can see that the splat render's color space is ACG, but our splat is not looking the same. We can see that it has very different color space, and we can actually compensate for that with the geo color space node. So this means we can tag an input prim with a specific color space and let it know that, hey, actually the color space is known. So I'm just going to put it into our 2D render so we could see, and I'm going to change this over to sRGB encoded AP1, and now we have the exact same look as our 3D space. Now we could have actually baked that in before we wrote it out. That's okay. We have applied it here as well. So this time we can continue to work. The next thing I want to do is I'm going to integrate some fog into here. So I'm going to bring in this fog plate from our friends at Action VFX. And what I'll do is I will create a geo card because I want to place this on a card just in case we have our camera move and the camera's moving around. I want to make sure that it's going to travel with the camera. Now, how I can work with this and set up this card is I will temporarily make a GeoScene node. I'm going to plug my splats into it, and let's have a look and just bring this card into a better position for this. I would like it to cross over a couple of cards. I'm going to make it a little bit bigger, 8, and then I'll plug it into our GeoScene. So now we have our card. Let's just orient this much better. Okay, so we've oriented it. I can actually just plug the fog into the material slot, and I can see what it's going to look like. So we're going to do a bit of a combination, some of this fog as well as some grading. So the splat render has AOVs, and we can see that we have the Z depth turned on. So this is how we're going to be controlling our merge with the fog. So what we'll do is, first thing is I'll create a shuffle, and I'm going to shuffle out the depth so I can do some color correction visually. So we'll take the depth layer and then plug it all into our RGBA. And then I will create a grade node and make sure that the grade is set to RGBA. And then what we'll also do is create another grade node, as we'll initially create a grade. And let's just make a bit of a change like this. And we're going to plug in our grade node as our mask. Let me just invert it. So now when we make these adjustments, we can go and grade our Z depth. And maybe we're just going to exaggerate this a bit and make it a more of a foggy day here. Just like that. And then we're also going to be merging our fog card over this. So actually we need a scanline render, and our camera is already ready for us up above. We're going to use that same camera, and then we'll plug this into the merge, and then we're going to create a screen here. And let's go ahead and actually grade this up a bit further. And I think we want to offset this card a bit more. Great. Now, also going to use this grade node for that, and then we can better integrate the fog card. There we go. All right, so we've used the Z depth AOV out of our splat render, and now last thing we're going to do here is create a defocus. So let's go and create a Z defocus node. We are going to plug it into the mix, and we will exaggerate this a bit, I think, but let's go and pick a focal point. Actually, the blur seems to be okay, the amount, and then we can see we have that Z depth passing through our chain, and then we can go in and make those adjustments. So this looks pretty good. So from here, if we look back, what we've done is we brought in a splat. We have isolated an element from it. By deleting points, we've transformed it to a new location. We've graded the splats, and then we've written out those changes to disk. And then from there, we've adjusted the color space, used the AOV for the Z depth, and then did some compositing work on it. Now, next thing we'll take a look at is some of the other AOVs inside of the splat render. Is we have motion blur, which is pretty self-explanatory, but then we also have deep, and we're going to see how we can utilize deep in our workflow. All right, so let's walk through a bit about how we can be using deep as well. So in this case, we have this splat, and we're using a field shape to remove this castle, as we're going to replace it with another object. And this will give us an example also how we can meld the 3D space inside of Nuke, merge them together with the splat world. So we saw a little bit about that earlier, and let's look at it with the 3D object. So in this case, what we have is we have our splat that's set up, and we're ready to insert a different piece of geometry inside of here. So on the 3D side of things, we have our mesh here. Let's collapse that down. And then we are adding just basic surface nodes to apply the texture, as well as just an additional fix for this area up here. And then we are placing it into position. So we saw earlier with the card, we're just doing a temporary geoscene, placing the geometry where it needs to go. And in this case, we're using a light here from the 3D space, one of the new lights. So we're getting a directional light. So now what we're doing is we have the scanline render that is rendering out. So we have two passes. We just have a really harsh key, and then we just have an ambient light. And then we're achieving this in the scanline render. We have the lighting set to on, and then in the secondary one, we have it enabled as off. Now, by default, we get deep data directly out of the scanline render. And in this case, I'm bringing it back into 2D, and then we're going to bring it back into deep from image, just so I have control over the ability to dial in that additional light. Now let's look at the splat render. So we know that the splat render has deep ability, and it has an alpha threshold. The default is 0.5. If we plug that into a deep sample node, what we will do is we'll see all the deep data that we're getting out of it here. Now, if I was to really lower this alpha threshold to 0.1, you can see that we're not sampling very much data at all. It's quite light. So if we want to speed things up a bit and we're not going to be using the deep, we can really dial this down as well. Now let's see if we leave it low like this, we want to do a merge. Let's see how that works. So we have already prepped our geometry that we're going to be bringing into it. We have the splat render that is already creating deep data. And then what we can do is create a deep merge set to holdout. And then in this case, what we're doing is we're using the splat to create a holdout on that geometry. Now, this is very powerful because, you know, we can have this piece of geometry, not necessarily this one, any piece of geometry, move through the splat, and we will have the appropriate cutout for it. Now, if we examine this cutout, you can see that it's a little bit, you know, blobby, and that is because we have very low samples, right? So we put the alpha threshold very low. So let me crank this up to 1. You see we have a much more detailed holdout now, right? We have all the trees. We can see through the trees. We can see the branches, the leaves, etc. So this is more along the lines. If we were to have a task like this, this is the result that we're looking for. So from here, we can do any corrections that we want to the actual geometry itself. And then we're merging it back with our splat. And now it's sitting in behind those trees. So a really nice way that we can be utilizing the 3D as well as the splat world, using that deep data to get proper holdouts for any of the geometry. And that way we can meld them in together. Earlier, we talked about the fields being able to manipulate volumetric data, and we can also be doing this with deep. So if we have two deep reads that are combined into a deep sample, I'll create a geo points node. And from here, I will plug in the camera from the 3D scene. And then now we have our deep data as points. And so from here, what we can do is create a geograde, and I will plug in the grade, and I've set up a simple sphere field shape, and we'll use that as a mask. So in this case, what we can do is now begin to grade just on those areas of points. Let's have a look, and you can see that we are affecting what is again inside of that field shape, and the field shape only. So quite a few options that we have with our field shapes as it expands out into other areas of Nuke. Let's dig a little deeper into our field nodes as well as show some hidden nodes. Now, we saw earlier when we have our fields, we can go under the display tab and we can draw a preview. And this is very helpful to see what volume is being encapsulated inside of our field node. So we can really visualize the shape of what it's looking like. Now, we couldn't do modifications to this as well. I'm just going to grab the field shape modify, and then we will look at the preview for that. And this has a rounding option, so we can actually go in. We can make it much rounder as well. And we have different shapes and operations that we can do. So we may have a bend, maybe a twist. where we can go in and begin to make modifications. So again, that preview is really helpful to see the overall shape when we're dealing with volumes. Now let's also look at some hidden nodes, and we can just go into updating all of our plugins. And once we do that, if we go under F, we will see some field nodes that are tagged as labs. So these are Foundry labs nodes. These are experimental nodes that you can begin to explore. So there's quite a few in here. And if actually we look under G, we'll see some geo field nodes here as well. Okay, so what we'll do is use some of those. Let's use the geo field warp. And this wants a field to be plugged in to begin to warp it. So we're going to use our field shape, but let's make some modifications to this as well. We will make a field warp node, different than the geo field warp, just the field warp. And this wants a couple of fields inside of here. So I'm going to give it the field and then the shape that's going to drive the warp here. So what we'll do is we'll create a, let's say a field noise, and we want to visualize this. So let's draw the preview and we can see the noise here. And then we will plug it into our field warp, and let's turn our draw previews on so we can see all of the preview from all of our fields. So we have our original shape, we have our now warped shape and the driver of the warp. So if we were to grab our field node and our noise and maybe just change the time, we can see that here. I'll turn off the preview for this guy so we can see this a bit better. So now we are using this field warp. We're modifying our original box, and we're getting an output from here. We can even add something else here, which is another Foundry lab, which is a field curve. And we can begin to crush the noise and make a modification with using the curves tool. All right, so with that, we will use this as our driver for our field warp. I'm just going to lower the amount for now. Now, what it's asking us for is a path. So we'll use the pop-up for the scene graph, and I'm going to choose the item that I want to warp, which is the splat. And then there we go. So now let's go in and make the amount a little bit higher, and we can begin to see the warping happening. So quite interesting as we can manipulate the shapes of fields using other fields and then have them drive an operation inside of our node graph. Another interesting labs node is the field volume node, where I'm looking at a VDB. I have a camera in here, and then I have a field renderer, and we can go ahead and render out that volume. So we can see the power of the field system, and we're just scratching the surface of the potential for future workflows inside of Nuke.
Hi, this is Jessie Burgess from Foundry, and today we're going to look at the new 3D system in Nuke. In Nuke 17.0, we are excited to have a focus on everyday workflows for artists such as projections, MaterialX standard surface shader support, and updates on how we will work with lights and cameras, along with new features in the scanline render. So let's jump in with how we can import our USD scene. Using the Geo Import node, we can point the file path to a location on disk containing our USD scene. This will open a scene graph. Here we can import our prims. We can search for a particular prim type or path name, for example, Geo. We can filter by lights, cameras, materials, and meshes. We can set the graph depth. We can highlight payloads, activate, deactivate prims, and in this release we are also now able to support Alembic files in the system. So through the scene graph we are able to pick exactly what we want to import into Nuke. However, on the Geo Import node we have a scene graph tab, so you can always come in here and adjust your selection after import. Building on the USD workflows we have been working on, we also have the Geo Reference node. This node is still in beta in Nuke 17.0. but we're able to import a USD file path and then set the prim path to filter exactly what we want to use at this point. So as a comper, these two nodes save us having to go back to the 3D team to ask for a specific data. We can get what we need when we need it inside of Nuke from the shared USD file. Cameras can now be extracted from the USD file by first creating a camera inside of Nuke and plugging the scene input into our GeoImport or GeoReference node. Then on the camera node's properties, we set the source prim, and you can see it opens up a scene graph with the filter already set to camera. So we'll pick the camera that we want to work with and click OK. So because we are loading the camera in from a USD file, you'll note that the knobs now have this green outline. This is showing us that it is a live read. But in Nuke we do have the ability to override the live read values. So for example, for this focal length, if we change that, you'll see we now have a yellow highlight over our knob value, and we have this yellow circle next to our knob. But if we click on this, we can always revert our changes by selecting no change, and that will remove the override that we had applied. We could also override the values by using the GeoEdit camera node. So now that we have our camera and our mesh, we want to project a texture onto it. So first thing that we'll do is we'll duplicate this camera and plug it into our GeoImport node. Then by using a frame hold, we'll make a projection camera. In this example, we're going to use the first frame. So now that we have our shot camera, our mesh and our projection camera set up, we now need to set up the texture that we want to project onto this mesh. Here we already have our projection texture imported into Nuke and set up ready for us to project. To project our texture, we use the Project 3D Shader node. We plug the camera input into our projection camera and our second input into our texture. Then, to project this onto our mesh, we need to use the GeoBind material. We can plug our input into the GeoImport node and then our GeoBind material into that Project 3D Shader. Now when we view that, we have our projection on our mesh, and we can have a look through our shot camera. It's now time to set up the scanline renderer so we can check out our projection in 2D. The new scanline render 2 we introduced in 16 supports ray tracing, exporting of AOVs, motion blur controls, and using the masking knob to isolate or remove prims from the render without having to go upstream. And we'll have a look at some of these features later on. We'll plug our shot camera in and then our scene. The first tab of our scanline render properties now contains the knobs that we need to set up our render. From the sampling to the camera and projection types, we can pick how we want our motion blur to be affected, ray options, material, lighting, and our scene masks. There is also a new Outputs tab where we can set up any AOVs we would need for our render. So now looking at our render in 2D, we can see we have our projection. We can then finish our shot with any other comp work needed. Inside of Nuke, we can also create sticky projections. Again, using GeoImport to import our USD file. In this example, we're going to project on falling paper. To create a sticky projection, we need to use the GeoProject UV node. We can plug that directly into our GeoImport. We then need to create a camera, whether that comes from USD or inside of Nuke, and plug that into our Access Camera input. Then, by using a reference frame on the GeoProject UV node, we are able to stick our projections to the mesh. In this example, I'm going to use frame 1. We then want to bring in the texture that we are wanting to project. To project this texture, all we need to use is a GeoBind material, plug the material input into our texture, the input into our GeoProject UV, and view that GeoBind. So you can see now we have our projection stuck on them. With the ray tracing support now in the scanline render 2, we are able to render reflections and refractions inside of Nuke. In this example, we want to add some reflections to the helmet. We've already got all of our tracking done, so then we want to set up if we don't already have our reflection texture, which is what we're doing here. We then want to import or create the mesh that we're going to bind our reflection shader to in the 3D space. Then, using the reflective surface node, we can plug our reflection map into the reflection input, and then we use a GeoBind material to bind our map onto our mesh. To create the reflections, we then import our HDRI image, and we use it as the map input to an environment light, using a geoscene to bring our two elements together, before connecting it to a scanline render, taking its cam input from our tracking earlier. Then, looking at the 2D space, we have our reflection, which we can then screen merge over our plate. We now have control inside of Nuke to adjust the mix of our reflection based on how reflective we want this helmet to be. We can add any additional nodes needed to help comp this into our shot. Then we can complete our shot, adding any other elements needed. Here we have a more complex shot, where we are wanting to add a couple of comp elements, such as some reflections to the windows, and then also some flame out the back of the engine here. In this example, we are importing our USD file using the Geo import node. Then, viewing through the shot camera, we can use the Geo activation node to isolate the glass on the helicopter. So either we can use our scene graph to pick the path that we want to mask, or we can use the eyedropper and just select the glass from within the viewer. Viewing the Geo activation node, we can see that glass is now isolated. Then, as we did before, we use an HDRI image, we plug it into the map of our environment light, add our light into a geoscene node, and then use a reflective surface and a GeoBind material. Viewing the scanline render, we now have our reflection for the windows of our helicopter. So by using a merge, again we can use the mix to adjust the value of that reflection. The next job we have for the shot is to add flame to the back of the engine. Again, using the same USD file with our Geo import node, but this time we're going to use the Geo activation node to isolate this engine, as we want to use it as a holdout mat. In some cases, we may need to invert the selection, which is easily done by clicking the invert selection on our Geo activation node properties. To create the holdout, we use a fill shader and a GeoBind material. To add our flame element, we add it to a Geo card and merge that into the same scene as our engine. This is the fun bit. Using a Geo constrain node, we could use the scene graph to create a path to what we want to constrain our card to. We then need to set the path of what we are constraining using the eyedropper tool or the scene graph, and we can type in Geo card. And you'll see that highlight in our scene graph. Making sure that our constraint type is set to parent, when we look through the Geo constraint, we can see our flame is now at the back of the engine. So we won't have to manually animate or track our card to the engine, which means if there are changes in the USD file, or if we have a new version of our asset, we won't have to redo any work. As long as the path name in the USD file doesn't change, that card will be parented to the back of the engine. Then, using the shot camera and a scanline render 2 node, you can see the engine here has made a holdout mat for us, and that flame is behind our engine. Merging that over our asset, we now have our flame in place. Of course, we could always go upstream and make adjustments to that flame element to get the look that we need. Then we can complete our shot inside of Nuke without ever needing to go back to that 3D department to ask for any additional data in order to do our comp tasks. In Nuke 17.0, we are now able to read in your textures with the new MaterialX standard surface shader node. This means we can plug in the corresponding texture maps into the inputs of the node. This node is not currently to import MaterialX files, but it is an extended shader support for Nuke to give more versatility than we've ever had before. It doesn't have full support for all MaterialX features, but we can import these files due to the Hydra support Nuke has. For example, we are now able to take advantage of using the normals to pick up lighting and shading correctly in Nuke, giving us more control when working with lights in Nuke than ever before. Here we have a flaw that we are wanting to replace inside of Nuke. So, by using the MaterialX standard surface shader node, we can plug in our texture maps to the corresponding inputs. Then, plugging our MaterialX standard surface shader node into some geocards, we can build the floor inside of Nuke's 3D system. Just to show you the difference between what we previously had in Nuke to what we now have with MaterialX Standard Surface node, if I disconnect the normal input, and you'll see the difference in this floor texture. The light nodes have also been updated in this release to be more user-friendly and to give us more control. Within the viewer, you'll see the new look for each light type. You may have already noticed this when we were working with the environment light earlier. We are now able to see the exact light we have in our scene and how it is affecting our texture. Then by using the scanline renderer, we have our 2D output, which we can now merge on top of our original plate, along with some other nodes needed to complete the shot. Another example of the MaterialX shader node is the control we have over the coat or coat normal. Here we have a set extension where we need to match the bricks to our set. By setting up our MaterialX standard surface shader node and our scene, we have the controls in the node properties to adjust the shader. So as we adjust the coat values, you'll see the difference in the viewer to how the light will affect the bricks, and we're able to match this to our plate. In this release, we have also added support for the Autodesk standard surface files. By using the Geo import node, we can load a material library through a USD file created in another DCC. Using the Geo import node, we can deactivate all other prims except for the materials using the scene graph pop-up on import or the scene graph tab on our node. So you can see here we have it filtered based on materials and everything else is deactivated. Then on the Geo by material, we're able to pick which material we want to use in our scene. So by clicking on our scene graph, you can see we can pick between the different materials within that USD file. So maybe instead of the balloon material, we want the plastic material in our car. So we're able to quickly switch between the different inputs through the GeoBind material. So maybe instead of the plastic, I want to have the velvet material on our car. After making these changes in Nuke, we are then able to export all of these changes into a USD file to be shared with the wider team. So using the Geo export node, which is now a yellow node to match the 2D right node, we just need to set the path and the name of the USD file that we'll be exporting, and then we can pick between USD, USDA or USDC, and then click execute. This can then be brought back into Nuke with a Geo import node or be shared with another artist. This is only scratching the surface to the changes in the 3D system. Keep an eye out for more videos and explore the documentation for additional information and the release notes for a full list of updates.
Join me as I go through a mock review scenario to highlight some of the new annotation features in Nuke Studio 17. I'm going to switch over to a custom annotations workspace I built. It gives us a bird's eye view of everything in the annotations panel. You can toggle them on with the icon, but honestly, I just click on a note and not only do the tools activate automatically, but it also jumps me to the first frame of the annotation.
Wow, I'm already impressed.
It really helps when you're jumping through versions. Speaking of which, check this out. I'll hit V on the keyboard to show me all the available versions of this shot. The notes stay pinned to the specific version they were made for. Version 7 says bump exposure. Version 8 says fixed color space. Version 9, approved. That's the dream right there.
If only they were all that easy. What about the trickier fixes?
Well, like this one, reposition eye further back. Instead of just typing it, I'm using the new clone stamp tool. It's brilliant because instead of the artist guessing where the eye goes, I can give them a literal visual guide right there on the frame. I'll just add a text note that says follow reference so they don't miss it.
That beats a vague email any day.
Right? These new drawing tools are even better to work with, especially if you're using a drawing tablet. And for lighting notes, we now have a dodge and burn tool. I can select the new dodge brush and paint right in the viewer.
This is too easy. Let's go to the next note.
This shot is way too dark compared to the surrounding shots. I'll just toss a color correct soft effect right there in the timeline to bring it up. It's just for reference, but it gives the artist a target to aim for. Now, for these T-Rex shots. I actually want your take on the lighting. Let's jump into a sync session. I'll host, and can you join the sync session through Hero Player?
I'm in. I can see your timeline, but remember, I can't add grade nodes on my end in Hero Player.
No worries. I'll drive the grade node from my side. It'll pop up on your screen instantly. What are we thinking for the T-Rex?
We want to take a look at this area under the T-Rex to fill it in with some bounce light from the snow on the ground. It's looking a little bit flat. Then we'll also want to pop the man off the T-Rex by lifting the gain for a little more definition. I love using this new vanishing brush tool. It lets me draw without leaving an annotation mark.
Same. I can even set my own color so there's no confusion on who's pointing something out. Okay, there's a GI pass for the T-Rex and the XR, and there's also a channel for the man that I can use to grade both of them directly here on the timeline.
Yes, that looks much better. Wait, now that we've changed the grid, it looks like there's a rough edge on the man that needs to be fixed. I'll enter a note on my side.
I should see your note appear on my end when you enter it. Got it. Okay, last thing to do. This T-Rex needs motion blur, and there's a gap in the hand. Let's create a Nuke script for this shot. I'm going to right-click the shot and then select Create Comp.
Will the notes and annotations carry over to the Nuke script?
That's the best part. When the Nuke script opens, the annotations are right there in the script as a node. If there are multiple annotations, then the artist can just cycle through the keyframes to see them all. The actual notes are also displayed in the panel. It's total visibility. Once the artist renders their Nuke script, it'll come back onto my timeline for review.
Clean, efficient, and no guesswork.
Exactly. Now that our review is done, we can send these notes, annotations, drawings to the production database through a Python scripted submission tool. This new annotation system is really powerful. I can get really artistic with my drawings, and the annotations panel is a convenient central location to hold all my notes.
Nuke 17 introduces BigCat, a new node. It's a copycat but for a large dataset. Train once and use it across your whole show. So here is the focus example. Blur in, sharp out, trained across thousands of image pairs. What's new versus copycat is the built-in validation. The dataset splits itself and the model never trains on the validation data. So what you see is its honest performance. Data augmentation, flips, rotations, color shifts, all automatic. Smaller datasets with solid results. Custom loss functions allow you to mix standard loss with perceptual loss for better detail. And a BigCat saves multiple checkpoints along the way. That's BigCat. Train once, deploy everywhere.
There are different methods to upscale in Nuke. There are the ML nodes like the pre-trained upscale. There are category nodes that you can download and use. And then there's the total variational in-painting method, or the TVI scale. This technique is powerful as it minimizes noise while still preserving the edges. We can limit or increase the smoothing to have fine detailed control. The TVI scale upscales to a factor of 2. However, it uses the CPU, which can be resource intensive and slow. New to Nuke is an updated TVI scale that uses your GPU, which produces that same high quality output with amazing detail. We also now have an unpre-multiply mask that could be helpful when we're upscaling footage with an alpha. If we examine closer, we can see how well it handles the upscale. It's so fast we can chain another one and still have it play back. So depending on your GPU, you can continue to upscale even further.
Deep compositing in Nuke 17 renders up to 1.88 times faster, both to disk and in the viewer. This is a core pipeline improvement, no new nodes to learn, no workflow changes. Same deep tools, just significantly faster. New Python callbacks for graph scope variables. You can now react when variable is added, removed, renamed or changed, automatically, before callbacks run first. They can block a change and serve as a safety checks. After callbacks, fire once it's done. They trigger what comes next. UI updates, file saves, farm submissions. All automatic. One change, everything follows.
Support has been added for YCB-CR conversion and NCLC metadata atoms in the Nuke MOV reader and writer. This means HDR images can now be written using the Rec 2020 YCB-CR matrix value. You can also set the correct metadata for color primaries and transfer functions, which will be read and interpreted properly throughout Nuke and the rest of your color pipeline. The Notch LC MOV codec is now supported on Windows and Linux for both ingest and export. This allows high-quality footage to be prepared in Nuke for efficient real-time playback in virtual production pipelines, including Nuke Stage. Notch's LC visually lossless compression makes it ideal for optimized high-resolution playback on LED volumes and for on-set review while maintaining image fidelity throughout the pipeline.
Nuke 17 adds native support for ACES 2.0 via OCIO. ACES 2.0 is optimized for both HDR and SDR content simultaneously. Better tone mapping, improved color handling, and a smoother path from what your camera captured to what your audience sees on screen. OFX plugins in Nuke used to hit a resolution cap. That limit is now removed. Your favorite third-party OFX plugins can now process at whatever resolution your content demands. This matters for 8K, IMAX, LED vault content, and cascaded upscaling workflows. Nuke 17 ships with full VFX Reference Platform 2025 support. Same library versions as the rest of your pipeline, no version mismatches. Updated Boost, OpenColorIO, TBB, OpenEXR, etc. The new 3D system now runs on USD 2508. Pipeline TDs who need a different USD version can swap it via the FNUSD shim system. Nuke 17 ships with OpenAssetIO version 1, the first stable release. It also includes OpenAssetIO Media Creation version 1 Alpha 12, a standardized bridge between Nuke and your asset management, Flow, FTrack, or Custom. Latest Sony SDK 5.1.0 and SMTK 4.26 are supported. Two new recording formats from the Venice 2 camera. Cross-platform Mac, Windows and Linux.